Well, welcome back. I hope you're enjoying your Regents week here and not having to take too many exams. Unfortunately, we're not meeting as a group. I know you're all very, very sad about that. But you do have this assignment to work on. So before we dive right into it, we are definitely doing more volume with some washers and discs. So make sure you have your calculator handy. We're going to focus a lot on the calculator in this lesson. This assignment is due no later than Friday. I will be at school every day this week until at least 3:20, and feel free to text me, call me, email me, do what you need to do. If you need any help whatsoever, don't be shy. This is still part of your second quarter average. Don't be afraid to help one another out. Certainly that doesn't mean copy anyone's work, but feel free to work together. All right. So I know some of you feel really confident in your volume, but there's some of us that are still a little sketchy, so I really want to take the time to say this one more time. So here are our four functions: y equals 2 to the x, y equals negative x plus 8, y equals 0, and x equals 0. So let's go ahead and get them sketched out. And you can pause me, sketch yours, and I'll meet you back in a few seconds. I do think it's really helpful if you do them in different colors, just so it identifies the area that you're looking at. So if you've got some colored pencils, grab those as well. Okay, so hopefully it's very clear in my picture that the area that's described by all four of those sections is enclosed by those four different colors. And I think you would agree that this section in here is between the green, red, orange, and purple. So again, I want you to do the same thing I'm doing. Some of us weren't doing that last week and having some issues. Let's shade this section in before we go any further. Okay. So I'm going to run through 4 questions. Again, take your time, do it with me. Even if you're confident in yourself, just stay with me and do the same thing I'm doing, and hopefully we won't have too many issues. All right, so question A, we're going to revolve that shaded region that we just described, that's in my yellow here, around the x-axis. Okay, so I want to do a few things first. I'm going to go ahead and mark the x-axis with my rotation symbol. And I'm going to ask myself, is this a disc or a washer? And as I clearly look at this yellow shaded section, and again that's why it's colored in, is it clearly all sitting on the axis of rotation? And I would say yes. There's not any point where there's a gap between my yellow shaded region and this purple axis. So this is definitely a disc. Okay, so our disc formula is volume equals the integral of pi r squared. Of course, from A to B. All right, now the other thing I want to do, and again, everybody should be doing the same thing, is you need to label every point of intersection on there. So I'm going to start with the obvious ones. And I would say these purple and green intersect at 0, 0. Okay, and again, every intersection point's getting labeled. The red and green, clearly the x is 0, and if I plug that into into the red equation, I get 0, 1. The purple and orange is another nice point. I would definitely say that's 8, 0. And now the orange and red is going to be an ugly point, so you need to grab your calculator, and I want to store both values in. So again, throw them in your calculator, second trace intersect. That number is currently stored into x. You're going to second quit on the home screen, and you're going to say x stored into alpha a. And take that whole number and store it in. So let me say it again. Once you have the intersection on your screen, you're hitting second quit. Quit is next to the second button. Hit the x value and store into alpha a. Now you need to do the same thing with the y value. So all you need to do on your home screen now is hit alpha y. And your y is literally, they're in alphabetical order. I think it's on the number 1 if I recall. Alpha y, and store that into alpha b. And I'll just verify my numbers with you. For A, I had 2.4678 something, and B, I had like a 5.53215 something. Okay, but again, get those values both stored in. All right, now that I have everything labeled, I'm ready to draw my rectangle in. And I want to stress the rectangle should be in your shaded section only. Okay, so I'm going to draw it right here. Now, ask yourself, is this upper end always going to be on the red line, or does at some point it switch to a different color? And that's why the colors are so useful. I would say it's going to be on red until it gets to here, and then it's going to be on orange. So I definitely have to set up two different integrals. You notice the bottom is always going to be on purple. So they're going to intersect right here is where I'm going to split, and then I'd have a separate rectangle here. So let's say our volume equals, I'm going to describe this one on the left first. I'm going to say pi. And again, if you're stuck on the bounds, basically just take this rectangle and ask yourself, you can move it to the left until your x value is 0, and you can move it to the right until your x value is a. So I'm going to integrate from 0 to alpha a. Now since it's a disk, it's just upper minus lower. So that's 2 to the x minus 0 squared dx. And I'm going to add on to that another pi integral. This time I'm going to pick this integral up. It's going to start where they meet here at a to 8. And this time my upper minus lower, it's going to be my orange line, so that's negative x plus 8 minus 0 squared dx. And some of us found out last Friday how important those dx's are. Be very careful that you throw those in there. All right, the only other thing, and like I stressed last week, I'm just going to make a note to myself, I put that function in y1, I put this function in y2, and just carefully type it in your calculator. So go ahead, pause me, take your time, see what you get. And I've got an answer of 244.391. So when it comes to the AP, I just want to focus on point-wise. Typically these are 3 points apiece, each, A, B, C, etc., for a total of 9 points. And they'll give you 2 points for the setup, and 1 point for the answer. Okay, so it is important you type it in, right? That should be an easy point as long as you set it up correctly. So 2 points for the setup and 1 point for the answer. All right, let's go ahead and we're going to take the same area and we're going to rotate it about something else. So pause it, let's redraw this picture out, and please redraw it in your notebook. All right, so I've resketched my picture, and this time I want to find the volume when I rotate it about the line y equals negative 3. Okay, so first and foremost, and this is where if you were having issues last week, this is where it came from. I want you to draw your rectangle in the shaded region. Don't even worry about y equals negative 3 yet. The rectangle comes first. Okay, because I want to stress, that it's only sitting in the shaded region. You shouldn't have a rectangle anywhere else but in that shaded section. Okay, so now I'll draw in y equals negative 3, just down here. And hopefully you're clearly saying that it's a disk, or I'm sorry, a washer. You'll notice that this shaded yellow section is not touching, my y equals negative 3 line at all. There's this huge gap here, which means when you take this and revolve it around that axis, you're going to get a big hole, or a donut in the middle, or a washer as we like to call it. Okay, now the next important step is the brackets. Let me grab a different color. And I want you to draw 2 brackets in. Please don't draw another rectangle. I think that's where we were really botching it if we were having issues. You are taking a bracket from the top of your rectangle to the axis of rotation and putting a big R there. Then you are taking a bracket from the bottom of your rectangle to the axis of rotation and putting a little r there. There's only one rectangle drawn in the picture, and that's in the shaded section. So my volume formula for a washer is pi big R squared minus little r squared. Now, you'll notice I'm going to have to do this twice, and that's again because this second rectangle has that different upper. So I'm going to go ahead and get my washer set up for this one. My big R is from the top to the axis of rotation. My little r is the bottom to the axis of rotation. All right, and once you've got that, you've done the hard part. Now you're just going to throw it in your formula, and hopefully you're good to go. So I'm going to start with this left-hand rectangle. Volume equals pi integral, we know it's going from 0 to a. And if you're still stuck, let me just make sure you are describing the brackets, not the rectangle now. Describe the brackets. So I'm going from 2 to the x is my upper. Right here, there's the top bracket minus the lower one. So minus negative 3, which of course makes that a plus 3 squared. That's my big R. Minus, here's little r. The top of that bracket, which is on 0, minus negative 3 squared, which of course makes that a plus, dx. Okay, now I have to add to that. Make sure you have a plus sign. I've got to describe this second rectangle. Pi integral from a to 8. Describing the big R, it's on that orange line, so that's negative x plus 8 minus negative 3 squared minus 0 minus negative 3 squared dx. Okay, so I know that's a handful. Again, I'm carefully just going to label my y1, y2. I know this is y1, this is y2. And just carefully type that in, and hopefully we'll get the same answer. So pause it, try typing it in, and see if we're in the same position. I get a 656.083. So again, just a piece of advice, make sure you have this set in parentheses when you square it, so you should be typing in y1 plus 3 squared, and should have its own set of parentheses, minus, if you can do this piece in your head, I just usually hit a minus 9. But you certainly could type 0 plus 3 squared or 3 squared. But really take your time and be careful. All right, we've done, two fairly nice ones. Let's do one that's perpendicular to the y-axis. So go ahead and give yourself that same sketch again, and I'll meet back with you in a few seconds. All right, so you'll notice I have the same sketch, the same shaded section, and I'm going to put my rectangle in that same section. I just have to make a note that I am revolving around x equals 10. And that, of course, is your vertical line. Your calculator will not draw that for you. So I'm going to go ahead and sketch in x equals 10 here. Make a note. Now remember, your slice has to be perpendicular to that line. So I am going to have a horizontal slice this time. Now, again, I don't like to draw it right in the middle. I'm going to draw it down here and ask myself, is this always going to be on green, and is this end always going to be on orange? And I can't stress again, those of you that were messing this up, you were drawing your slice across the whole picture. It should only be in the shaded section. That is the key. And I would definitely say, no, I'm going to need another rectangle. As I move this slice up, clearly now, if I were to draw it here, it's going to be on red and orange instead of green and orange. So I need to put another slice in, and I think 2 would do it. All right, so this is definitely a washer. You'll notice all this empty space between my rectangles and the axis of rotation. So I know I'm going to have pi big R squared minus little r squared. And I'm going to go ahead and draw those brackets in. Okay, so again, it's from the rectangle to the axis of rotation. That's my big R. Other end of the rectangle to the axis of rotation, little r. I'm going to do the same thing on the other one. Big end to the rotation is big R, little end to the rotation is little r. All right, and now I'm just going to put them in there. So let me start with the larger one here. They can see I'm highlighting. And I'm going to write its equation first. So it's going to go pi. All right, let's talk bounds. This rectangle can slide not left and right, it can slide up and it can slide down. So your question is, how low can you go? And I would say, well, it's definitely to a height of 0, and you'll notice I'm going to box in the y values. That is my lower bound. Now, how high can that rectangle go? Well, it can't go all the way up because then it switches to this rectangle. So it can go right until these two meet, and that's where it's going to switch. Okay, so again, I'm going to grab the height, which is at 1. Now, the other fairly annoying, and I would say pretty darn annoying actually, thing about these is they have to be in terms of y. So I can't just throw those two functions in there. All right, so let me start by describing the big rectangle. I'm going right minus left. My right is sitting on 10. My left is sitting on 0. Minus my little rectangle. My right end is sitting on 10. My left end is sitting on this orange line, and you'll recall the orange line was y equals negative x plus 8. So I quickly have to solve for x instead, so I'm going to say x equals 8 minus y. And that's what I need to put here. Now you'll also note I'm going to use parentheses around that so I don't screw up any signs. That needs a squared, close bracket, and of course a dy. All right, if at any point I'm going too fast, remember, pause it, rewind it, try it again. Now, I need to add on to that the second rectangle. I'm going to scroll up a little here. So pi. Now this rectangle, okay, so let me highlight it. How low can it go? Well, it can only go until it gets to here. So that had a y value of 1. And it can go up till they meet here, which has a y value of b. So I'm going to go from 1 to b. Okay, I'm describing right minus left of my big R. Looks like my big R is on 10, and then it's on the red line. So I'm going to say that's 10 minus. So again, I got to go off to the side and solve this equation. I'm just kind of running out of room. Let me scroll a little here. The equation was, oopsie, not that. Oh boy. Y equals 2 to the x. Okay, and of course they're going to, make sure you can switch from exponential to log fairly quickly. There's two ways to simplify this or to convert it. You can just switch to log form, which is, of course, log base 2 of y equals x. Switching from exponential to log, most people say begin with the base. That base stays the same. And then your exponent is what you're equal to, so a little bit of algebra 2 trig. So that's one way to get to your answer. Or you could take the log of both sides. You can say log of y equals x log of 2. And the reason that's fair game is when you throw log in front, that's one of your rules. It brings the exponent down in front. And then to solve for x, I would just divide over log of 2. So I could say log of y over log of 2, which of course is equivalent to log base 2 of y. Those mean the exact same thing. Whatever works for you is fine. I prefer switching from exponential to log fairly quickly. I know the base stays in the same spot, and basically these two switch spots. So back to my equation. I'm going to say, oops, I better look at my picture again. All right, so I was describing my big R, which is going to be 10 minus, I'm going to say log base 2 of y squared, minus, my little r is going to be 10 minus the orange line, which is 8 minus y squared dy. All right, now, when you go to the calculator, let's just be very clear on this. There isn't a y button that you're going to hit. You can clearly only hit y equals. So when you go to type this in, I clear out what I have in y1 and y2 right now. Okay, I'm not going to use the 2 to the x and the negative x plus 8. I actually put this function in y1, and again, in my calculator, I have to call it 8 minus x. Excuse me. And then in y2, I would put this function. Okay, and I'm not going to look at their graph whatsoever. I'm just using them for placeholders. Those of you that have the update, another piece of advice. If you have the updated calculator, you have a log-based button. I believe it's alpha, everything new is on that top row. It might be alpha window. Alpha window, and you have the log base button. So you can type in any base you want. If you just hit log, it automatically assumes you have a base of 10. But again, if you hit alpha window, you should be in good shape. Those of you who do not have the updated calculator, the only way to correctly type that in your calculator is to use change of base form. And I'll kind of arrow over here, which is going to be log of y over log of 2. Base goes on the bottom. And again, your calculator, you have to treat that as an x. Okay, so I know I'm talking fast. If you're stuck, again, I'm at school all week. Come in and see me for some help. But let's carefully type that in and see if we get the same thing. And I get 893.240. Hopefully I typed that in correctly. But you can see, it's a lot of calculator work, a lot of, taking your time, watching the details, and obviously taking your time, but, hurrying at the same time. Okay, well, I think I'm going to be good with those 3 examples. And again, it should be, mostly review, just taking your time really with your calculator and being very careful when you're perpendicular to, the y-axis. Now this is just a snapshot of the worksheet. The worksheet is attached to the page that you found the video on. I just want to stress the directions here. There are 4 different regions, A, B, and C. You need to be very careful which one A, B, C, and D are. Also, you'll notice the directions say, show the setup to find each of the requested volumes and using your calculator if there is an asterisk next to the problem. So you just want to be clear, only if it has an asterisk are you actually going to get the volume. Otherwise, I just want to see the setup only. Okay, so part A, you're going to get the volume to. Part C, the other ones are just setup. If it has an asterisk, I want the volume. Use the calculator to get that, of course. The other thing I've printed for you, or attached for you, is a bunch of little graphs, and I've already color-coded them. You basically just need to identify who A, B, C, and D are, and you can, use each one, so you don't have to sketch it every time on your own. You can use, these graphs I drew for you, just print them out, and, identify each one with the problem. If that works for you, if you want to sketch them on your own, that's fine too. I thought I would just help you out a little bit. So let me just recap here. All of this is due by Friday. You can bring it up to school, leave it in my mailbox, leave it on my desk. You can take a picture, you can email it, you can drop it off, whatever you want to do, but I do need it by Friday. The other thing that you'll have due, of course, are test corrections if you need any help with them. Again, I am at school every day. If you just want to shoot me an email or text and let me know when you're coming just to make sure, you can find me. And lastly, you will have a video for a new topic for Monday. So Sunday night, I probably won't post it till Friday, but Sunday night sometime, make sure you watch the video for Monday. We will do a new topic. So I look forward to hearing from you. If you have any questions or need any help, just holler at me. Have a great night.